Okay, hello everyone. My name is Casper. I'm going to talk about using Inkscape and a plugin called SVG2Shenzhen and to export to KiCad to create printed circuit board designs. I just want to I have a little presentation prepared about all the different layers of the PCB, so I want to kind of know if I should skip through that quickly, or like how many people know what the different layers of the PCB are. Okay, so I'm going to go through this relatively quickly. The base layer is like a fiberglass layer, FR4. You get it in different thicknesses. 1.6 millimeter is probably the most common. You can get different substrates as well, but most PCBs will be FR4 fiberglass. On top of that, you have layers of copper, and the process for making PCBs really is to etch this copper to get your design onto it, to have the connections that you want. There's an image missing because the internet. I don't know which layer I skipped, but you. Oh, this is a. There we go. Right, cool. Right. So in the industrial PCB process, you have many of these copper fiberglass layers, and you have quite an accurate drilling, and another a solder mask layer and a silkscreen layer as well. So the mask layer is kind of like the color. When you see PCBs, the color of the PCB is normally the mask layer. You can get a transparent mask as well, and then obviously there's a lack of color, but you can get quite a lot of few different colors, and you can do multiple masks as well to get, but that's quite expensive. Silkscreen layer is where you put some information. It's normally white on green. This is like all of the references for the components are normally in silkscreen layer, but you can also add your little personal touch. And most people do that. You have a lot of different drill sizes, but normally on a board you don't want to make it too complicated for the manufacturer and use loads of different drill sizes. If they're just slightly varying, they'll probably clean that up for you and just use like a standard drill when the drill sizes are close together. So what you want to give to the manufacturer are Gerber files, which they specify all these different layers. And to make that, you can use KiCad. KiCad will export to these Gerber files. And so what we've been doing, me and friends of mine, and just a lot of people around the world, actually, you can if you're home etching, you can just draw onto a transparency, or draw onto paper and then get it onto a transparency somehow, and then use the lithography process to do home etching. So really, you can draw PCBs if you want to, and you're careful enough about where you're drawing the connections, and you're able to kind of process that mentally. You don't need CAD software. And Mark, just here, he does really cool workshops as well, where he scales up components in these kinds of transparencies, or these laminated bits, and they're 400% bigger than in actual size, and you can then use that to draw your PCB in big and connect everything up, and it's a really nice creative method of doing PCB designs. And I've done this as well, and I've got a little design here that I can pass around for it's a little oscillator. Unfortunately, I forgot the battery, otherwise you could hear it as well. We can pass this around, and there's another version of it where it's actually, I exported it to the professional manufacturing service, and it has a mask and silkscreen layers as well. But that can also that's quite kind of labor intensive to prepare all this and do it by hand and scan it, and then we would use the bitmap to component tool in KiCad to get everything in. So we wanted to have a different process for using these a graphical tool like Inkscape, and still and be able to draw PCBs in there. That's already half my talk, so I'm gonna just show you this. So we're going to start Inkscape. going to start KiCad in the background there. So this extension is called SVG2Shenzhen, and it's actually a fork of the bitmap 2-component tool. So it uses that to process the layers. The first thing we're going to do is just prepare the document. The sizes don't really matter. It used to have to be square, but not anymore. Somehow turn this grid on, which is kind of annoying, but you can just turn it off again. And then we can just draw any. So what it's done now is it's given you in Inkscape all the different layers that KiCad uses. So we'll go into the edge cut layer, and we'll just draw any kind of shape. Obviously, we'll do a nice rectangle. No, sorry. We'll do, let's do some kind of spiral. And just see if we can do another spiral and make this actually into an outline layer. Mm-hmm. So what we have to do with this, we have to make sure this is all a kind of one path. Combine this path, so that's now one path. It's a bit thick. So this is our edge cuts layer. We just need to make sure that's properly connected here, because it has to be, for the outline layer, you want one complete path. We just need to make sure it's connected properly connected there. Combine. Nope. This one's. So, yeah, right. I don't know if this is going to be manufacturable, but what you see as well, if you have them all, the PCB manufacturers, when you do something weird like this in the outline layer, because it's like such a fast and cheap process now, they will probably not get back to you and say, so there's something wrong with the way you've done the outline. They will try and do it. Like if you look at the fingers of the mold, they've just, because the routing path I chose there was really too tight for the CNC mill they use. They just drilled it where I had said there should be an edge like that, because they can't do that. So it would be interesting to see what they did with this. So we'll export that. We'll say export to KiCad. So you can either here do it as a PCB design, the output would be a KiCad PCB, or you can do a module. And we probably don't have time to do the module bit, but so this is a little bit awkward, but this is due to the limitations of the Inkscape plugins. I don't know if this has changed in new versions. We'll have to look at that if we can do this better. But we will say, you kind of have to know where you're going to put this. I'm just going to say I'm going to put this into this example directory. And by default, when you don't save your SVG yet, the name will be drawing. It's everything in Inkscape. When you start off, it's just drawing. If you save it as something else, then your export will be renamed as well. Right. So now that's gone here. I've already got this open, I think. I think it's overwritten this, hopefully. Nope. Okay. Let's just make sure. I normally don't use this desktop, so it's a bit. M? Wait, hold on, over here. So well, let's just remove this and then try the export again. So, maybe I didn't even press export before. But yeah, so there's a new PCB here, and it's not there. Right, something's gone wrong, unfortunately. This is all one path. So the trouble with the outline layer is really it needs to be one kind of path. The other layers, we can get, maybe I can show you this quicker, because the outline layer is actually a little bit trickier than any of the other layers. Because in these layers, anything you draw, it doesn't matter. You don't have to convert to path or do anything like that in Inkscape. You can just draw whatever you like, and it will be. It doesn't. The colors don't matter, so you can make it pretty much any color. But it just goes. There's the threshold, it converts it to a bitmap, and then uses that bitmap to make the PCB layer. So if it's above any kind of darkness threshold, this will be turned into copper layers. So let's do something a little bit more fun, maybe a star in this. So that whole star will be, we're on the front copper layer here, we've drawn the star, and we'll export that. And we'll open that here. Just open it again. Still not worked. What is going on?
File there.
Huh? Yeah, and I deleted the file and opened it again. So I had deleted this and then done the export. It's the demo effect. Oh. There we go. Look at that. So from there, we really the path, the most useful bit is then going directly into the 3D view and looking at what it is going to be. It doesn't look manufacturable, and generally, I have these rulers as well that I wanted to pass out, which is one project I did with this. Just pass these around and have a look. Ooh, that's my phone. Oh, that's the mic. Maybe. So just to kind of finish off, because I'm probably out of time, aren't I? I don't. What's my time? How's my time? How many?
Yeah, you should start your second talk now.
Okay. So you might, when I first sent off this PCB ruler, the email I got back is it's crashed our CAM software, so you can run into trouble like this. But really, when it's so cheap and like you can kind of play around and see what kind of test the limits of manufacturing. Yeah, so this plugin was developed by EOC, aka Bad Geek, and I think it's really like, for me, it's like how I kind of always wanted to design PCBs, and I would like, if you enjoy working this way and you use it, support EOC on Patreon, and I'm going to move to my second talk.